This is what we're going to be drawing today, a tree. It's going to absolutely blow your mind. We can make this picture with just 50 lines of code. That's why this is an absolute favorite among people that do algorithmic art. It is a rite of passage and a great introduction to the concept of recursion. So let's dive in and I'll explain what I mean. So I'm going to start with our usual boilerplate code for just creating a blank canvas and writing it out to a file. The crux of all this is going to be a draw tree function. And earlier when I said this is a great introduction to recursion, it's because a tree is a recursive structure, which means you can define it in terms of itself. The object appears in its definition. Let me show you exactly what I mean by that to clear that up. So to draw a tree, we're going to draw the trunk of the tree, and then we're just going to draw two other smaller trees on top of it. So this is what I mean by recursive. Draw tree references draw tree. A tree contains smaller trees. We draw the left tree and we draw the right tree. And this, believe it or not, is a definition of a tree. It really is that simple. If you're more of a visual learner, let me sketch out what I mean by that. So to draw a tree, we're going to start by drawing the trunk of a tree, and we'll just do that with rectangles. That's what this part is. And then we're going to draw another tree to the left, and that's just going to be, it's like the tree, so it has a trunk but like a little smaller, and to the left. So we'll put it where this trunk stops, and then we'll rotate it. And then there's another one that we want on the right. And then, because these are also trees themselves, to draw these, we have the trunk, but then we have smaller trees sitting on top of them. And you can see if I just continued this process, we would end up with a whole built-out tree that looks pretty similar to this thing. The only catch is, you'll notice that we can end up with an infinite recursion here. If we keep doing this, we never stop. We just keep drawing trees. So you need some halting condition. If we're trying to draw a tree that's too small, yeah, just give up. Just stop. Just return right there. All right, so let's actually write some code for this thing. Let's start with drawing the trunk, which is pretty straightforward. We're just going to draw a rectangle. That's what the trunk is. I'll make it black, and then we're just going to fill in a rectangle. Yeah, let's give it a width and a height. I'm going to pass in the height as an input here, because we're going to want to be able to do something like this to draw the subtrees. Want to make them smaller versions of the tree that we're currently drawing. The height will be this, and then to make these look normal, we're going to want the width to be some multiple of the height, so we have some constant aspect ratio, and we can pull that out into a constant, so we can tweak it later to get different looking trees. Call that trunk width ratio. Let's do something like 0.2 for now, and again, we can just play with this later. So we'll say width equals the ratio times the height. Cool. And I actually want the trunk to be centered at 0, and I'll explain why that is later. But that just means I'm going to start drawing at width over 2 instead of at 0. Awesome, so that should be a good tree trunk. Now we have to figure out how to draw all these subtrees. Let me go ahead and factor out their heights too. So we'll call this the branch size, and that's just going to be some constant. multiple of the height. And we can also pull up that multiple as another constant. Call that branch ratio, let's say. And this is going to make it super easy for me to tweak what the tree looks like by playing with these numbers. So we're almost there. Another easy part we can fill in is we can fill in this. Let's say if the height is less than some number, we can also make that another variable. Let's call that our smallest tree. Do for 3 for now. If height is less than the smallest tree, just go ahead and give up, and that will break the infinite recursion. We'll quit calling draw tree. All right, now all we have to figure out how to do is draw these things. The catch is that the base of these trees, these children of this one, so we just drew the trunk. Now we're trying to draw these ones. They start at the top of the trunk and they're rotated. So they both start in the same place, so we can unify that logic. We just need to translate up so that 0, 0 instead of being here is up here. That's pretty straightforward to do. We just take the canvas, apply a translation, move it up based to the height. So again, that just makes it so that this is our new center, the top of that previous trunk that we just drew. And then they each need different rotations applied to them. So I'll do the rotations within each of these sections. And we're gonna need to undo the rotations after we're done drawing that part. So I'm gonna use this save method, and saving just means, yeah, I can restore when I'm done. So whatever I do to draw this tree, I'm just gonna undo it at the end. I'll do the same thing here. And now all we have to do is apply the rotation. And yeah, that's just super simple. We do something like this. Again, it's gonna be nice to factor that out into a constant so we can tweak what these trees look like. Call that like branch angle. Pi over 4 is kind of large. Let's do pi over 6 to start with. And I think we might be done. All that's left to do is actually call draw tree and give it initial height. So let's say that initial trunk, we'll just make it 100 pixels. Since our canvas is 400 pixels, that should be a good height. One other thing, just going into this for expectations, is the way that this canvas package works is the top left of the screen is 0, 0, and then we increase the number as we go down and to the right. So the way that we're drawing this, where the trunk starts at 0, 0, is centered at 0, 0, and has width and height, we're actually drawing the tree upside down and starting from the top left. That just makes the math here simpler. But let's go ahead and run this. You'll see what I mean. Boom, we got it. Of course, we're only seeing the left half of the tree because the right half of the tree is off the canvas over there, and the tree is upside down as well. So you go ahead and fix that just by applying some transformations to the canvas as a whole. So again, I said that 0, 0 is in the top left here. So we actually want to make 0, 0 down here in the bottom center. Yeah, I think I actually just opted the right translation. That's exactly what we want to do. So this is the bottom of the screen. This is the center. Start at the bottom center, exactly. It's like it's listening to me. And then the other thing that happened is we drew it upside down. So we also need to apply a 180-degree rotation. In other words, pi radians. All right, let's try this again. Awesome. Isn't that incredible? Less 45 lines of code. All the logic is basically this. A tree is draw a trunk and then draw two other trees. And those are just offset and rotated. Let's go ahead and play around with some of these values. So the width ratio, this is basically how chunky the tree is. This will be a pretty chunky looking one. That's too much for my taste. I kind of liked 0.2. Could go maybe a little thinner. That's looking a little thin. All right, branch ratio. Branch ratio is how small the children are relative to the parents. So if we want to like make them much smaller and decrease that, yeah, that's kind of weird. And we also hit our limit, our smallest tree limit, pretty quickly doing that. That's a little better. They're still pretty small though. That's looking better, but I think I like 0.7. Let's actually try a bigger value. We can't go bigger than 1, of course, otherwise the children will be bigger than their parents. Wow, that's a lot going on. That's crazy, the difference between 0.7 and 0.8. Maybe something intermediate? Yeah, that's kind of nice. I'll hang out there. Smallest tree I'm happy with. Like if we make this even smaller, you'll just see more of those tiny branches at the end get added. And if we make it bigger, then we'll quit drawing the tree soon. And then branch angle is how much these things bend relative to the parent. So if we make this smaller, we'll get a taller, narrower tree like that. And if we make it bigger, we'll get a more sticking out tree. That's crazy because these are 45-degree angles now. So this looks highly geometric. I kind of like something like this maybe. That's a little too tall. Okay, that's looking pretty nice to me. Not quite as geometric as when we have the 45-degree angles, but still looking highly geometric because all of the trees are identical to all the other trees in this recursive structure. If we want to break this up, instead of having hard-coded values for all of these, we can actually randomly pick a value from a distribution. And using a normal distribution is a really natural choice here. So I'm gonna go ahead and bring in a package that will let me easily sample from a normal distribution. I'll import it. And then again, instead of having fixed values for all these things, we can just sample them from a normal distribution. We'll use a normal distribution centered at, yeah, something like 0.1 with a standard deviation of 0.02. And let's do similar things for the rest of these values. So we'll replace all these with normal distributions. Smallest true we don't need to. We can hard code that in. We'll just quit drawing at some point. Looks good to me. And then we just need to update the code here. These things return funcs. So this is now a function that can be called to give me a number sampled from that distribution. So we'll get a different value here each time that draw tree is called, which is exactly what we want. So again, what I'm trying to accomplish here is that the way we've been drawing this, it's very geometric. This is going to introduce some more randomness into the result, which hopefully makes the picture look more organic. Okay, yeah, definitely looking, see, we're getting some differences here. All these trees are actually quite small. I wonder if it's because these look much more organic though. Why are these looking so small? I wonder if it's that this branch ratio is quite small. Let's bump that up. Yeah, there we go. Getting some larger trees. The trunks are looking a little thin to me. Let's also play around with this. That's too much. A little better. There we go. I'm liking the look of these trees. That's a pretty good looking tree. So that's it for this drawing. It is absolutely mind-blowing to me that this little code can produce something like this. Again, the whole idea is recursion, that we just define a thing in terms of itself and keep running that process until we hit some base case. As always, I'll link to the code. Go play around with it and make this thing your own. See you next time.